Hello everyone, my name is Jenny Kim. I'm also known as Julian, and today we'll be discussing annuities with a particular focus on home mortgages. Now, I believe that understanding personal finance is crucial, especially given today's challenging housing market. So I encourage you to take a moment to listen in and gain some insightful knowledge on the housing market. So in this video, I'll explain the concept of the present value of an annuity, professions within the annuity and mortgage field, how to calculate your monthly mortgage payment, the total interest paid over the fixed interest period, and why opting for a shorter mortgage term is often a better choice in the long run. So the present value of an annuity is the amount of money required today to fund a series of payments in the future. Due to the time value of money, a dollar today is worth more than the same dollar in the future. An annuity is essentially a loan with equal monthly payments. Although that monthly amount remains constant, the composition of that payment changes over time, with a larger portion going towards interest early on and more towards principal as the loan progresses. A mortgage is a common example of an annuity. A key professional role in the world of annuities and house mortgages is the mortgage underwriter. These individuals, typically employed by banks or other financial institutions, verify your identity, check your credit history, and assess your financial situation that includes your assets, any debt, and your income. They are the ones responsible for approving or denying mortgage loan applications. Now, purchasing a home is a huge milestone. It's incredibly significant, and it is often a complicated process. So what happens once you're approved for a loan? What happens once you purchase your house? Let's explore 3 application problems to see how your monthly payment and total interest paid can vary depending on the length of your mortgage term and your down payment. With these application problems, we can figure out which variable would affect it negatively or positively. So with our first application problem, we'll be looking at Jeremiah the First. Jeremiah the First is considering purchasing a house priced at $300,000. His lender requires a down payment of $50,000, and this leaves him with a remaining balance of $250,000 that needs to be financed through a loan. With a fixed annual interest rate of 4.5% compounded monthly and a mortgage term of 30 years, we need to determine 2 things. 1, how much will Jeremiah the First pay monthly? And 2, how much total interest will he have paid after the 30-year mortgage period? In order to calculate the monthly mortgage payment, we will reuse the payment annuity formula. On the slideshow, I have the payment annuity formula listed, and the reason why I say reuse is because this formula would solve for P0, which in our situation would stand for the principal loan amount. However, since we are given that value already, once we input our values in for each variable, so R is the interest rate, and our interest rate is given as 4.5%, which when translated into decimals is 0.045. The N is the number of compounding periods. So since the paragraph lists the interest rate as compounding monthly, N will equal 12. T represents the mortgage. So since Jeremiah the First has a 30-year mortgage, T will equal 30. And as I said earlier, P0 is given to us in this case with our principal loan amount being $250,000. Because W is the only variable we aren't aware of, we want to reformat the payment annuity formula to solve for W. We can do this by first getting rid of the denominator, so multiplying both sides by R over N. Then we want to divide anything that's on the same side of the equation with the variable W. So we want to divide that hard bracket out onto the other side. That leaves us with the isolated W equals P0 times R over N over hard bracket 1 minus parentheses 1 plus R over N to the negative N times T power, close bracket. So once we get that rewritten formula, then we can start to substitute in our values. So once you substitute in your values in your calculator, be particular about where you put your spaces, your brackets, your subtractions, your negatives. Once you put it in properly, you'll get the number $1,266.71. That number is Jeremiah the First monthly payment. Once we get his monthly payment, we can find the total interest he paid over a 30-year period. We can do this by taking his monthly payment, multiplying it by the compounding number of periods, as well as the overall time within his mortgage. So multiplying the $1,266.71 by 12 and by 30, that'll give us the total amount he has paid, including principal loan amount as well as interest. That number being $456,016.78. So that is the total amount, but we still need to find the interest he paid. We only want to know about the interest. So we want to subtract that number by his principal loan amount, which was $250,000, which gives us $206,016.78, of which all of that is just interest. So we can see in Jeremiah's case that he ended up paying a significant amount of interest. He ended up paying more than half of interest of his original home value, since his home was originally $300,000. He paid $200,000 of interest in addition to that. So what can we do? What can we adjust so that we end up paying less interest over time? Would it be better if we increased our down payment? Would it be better if we decreased our mortgage? We will see with the next two application problems. So in application problem 2, Jeremiah II wants to purchase a house, but he wants to learn from his father's mistakes. He purchases a house priced at $300,000. However, he puts down $60,000, so more than his father. This leaves Jeremiah with a remaining balance of $240,000 that needs to be financed through a loan. He gets the same annual interest rate, so a fixed annual interest rate of 4.5% that is compounded monthly, and a mortgage term of 30 years. So same thing as earlier, we want to find out how much he will pay monthly and how much total interest will he pay over the 30-year mortgage period, so we can find out and compare if it is better to have an increased down payment rather than not. So using that same formula that we found earlier, which is the W equals P naught times R over N over hard bracket 1 minus parentheses 1 plus R over N to the negative N times T power. We input the new values we're given. So our new value is the principal loan amount being $240,000 rather than $250,000. When we input those values, we get the higher monthly payment of $1,216.04. So same thing as earlier, we want to take that monthly payment and multiply it by the number of compounding periods as well as his overall mortgage. So when we multiply that, we are given the total amount of $437,776.11. Now that is that total amount. So we still want to subtract our principal loan amount to find out what is the interest, to only find out what is interest. So by subtracting that $240,000, we get $197,776.11 of interest. Although that still sounds rather high, if you can look on the slideshow, as you can see, Jeremiah I still paid $8,240 more than Jeremiah II. And he ended up paying more even though Jeremiah II just put a little bit more on, $10K more on in the initial process. So yes, you could theoretically save more interest. You can save on interest if you put a bigger down payment initially. However, what would happen if you had the same down payment, you had the same interest rate, but you had a shorter mortgage? Let's take a look with the third application problem with Jeremiah III. So perhaps the savings weren't enough for Jeremiah III. He wants to save even more than his father, Jeremiah II. So he purchased a home priced at $300,000 like the men before him. But unlike his father, he chooses to put down only that $50,000, which leaves him with a remaining balance of $250,000 to be financed through a loan. He gets the same fixed annual interest rate of 4.5% compounded monthly. However, this Jeremiah chooses to get a mortgage term of 15 years. So we want to answer the two questions of how much will Jeremiah III pay monthly and how much total interest will he have paid over his 15-year mortgage period. Using that W equals formula again, we want to input our new values. So our new values this time is we have a shorter mortgage, so T will equal 15 since it's a 15-year mortgage. And our P naught term will return to the principal loan amount of $250,000 since he chose to keep the same down payment as Jeremiah the First. When we input all our new values into the calculator, we'll get the highest monthly payment of $1,912.48. So although he has a higher monthly payment, once we multiply that by his compounding periods as well as the time with the mortgage, so times 12 times 15, we get $344,246.98. We subtract that by its principal loan amount, which is $250,000, and we get $94,246.98. So in comparison, Jeremiah III only paid $94,246 in interest, whereas the other two were in the even the six digits. They paid a significant amount more compared to Jeremiah III, and that's because Jeremiah III had a shorter mortgage period. So in conclusion, though the monthly payments may be higher, you will pay less interest over time with a shorter mortgage term. I hope that this lesson was beneficial to you, and I wish our generation good luck when facing the wild west of residential real estate. Thank you, and here are my references.